Welcome student in our today's online section of subject mechatronics. Here we are. So today we are going to start our chapter number 2 and name of this chapter is data acquisition and signal communication. Okay, so here. So what is the syllabus of this chapter number 2, which is data acquisition and signal communication? In this chapter, firstly we are going to study about the signal communication, then we will study about the data acquisition. So what is the signal communication? So in this signal communication, how the signals are sent between the sensor and the receiver is we are going to study. Then there are the types of signal communication, which is series, parallel, then synchronous, asynchronous, then introduction to data acquisition. Then we will see it. Then we will see the types and components of data acquisition. This system, which includes sensor, signal conditioning, processing, controlling, and storage display and action. Then the separate part of data acquisition we will study in the same chapter. So here we are going to start our first part of this chapter number 2, which is signal communication. So here we are going to communicate the signal. You know what is the signal? Signal, it is the change of something, or it is the change in the measured quantity which is sent from sensor to the receiver. So here you can see a signal is a function of time or frequency, means as the time change there will be the change in signal, so we call the signal as a function of time. That stores information about the behavior of certain phenomenon. So behavior of certain phenomenon means if you are going to measure the speed and the speed is exceed beyond the limit, then one signal will be sent to the controller. So signal, it is the information about the behavior of certain phenomenon. So you know, you may mainly hear in some automated vehicles that when the speed exceeds the maximum volume or extreme value, at that time a signal is sent to the controller and controller reduces the speed. Means here in that case of speed exceed, in that case here we are going to send a signal of this speed, means behavior of this speed, and its signal is sent to the controller there. So here again the data transfer takes place through the signal communication over a point to point and point to multiple communication channel using a optical fiber, copper wires, and wireless communication. In a signal communication, data transfer through electromagnetics such as electric voltage, radio waves, microwaves, or infrared signals. And there are two types of the signals. First one is the analog one and another one is the digital one. This analog signal, it is having a continuous form, and digital signal, it is having a quantized form, means it is, you may say, it is having a discrete form. The mostly device which is analog and digital you can see in practical life are the watches. You know, in the analog watch which is having a clock, which is having a hand clock, or this analog watches are the watches where you can see this 1 to 12 as a numbers on which the hands of this clock are continuously rotating. The hands are second hand, minute hand, and the hour hand. So at that time continuously the second hand is continuously rotating and you get the continuous form of signal there. But in case of this digital watch, you will not get this continuous signal there or continuous signal there in form of the digital watch. You will only get it is in the form of the quantized, means you will only get this value as 4 am, 4 minute, 4 hour 1 minute, but it will not send about the continuous signal. It will send the signal in the form of the minutes there. So it is the digital watch, digital form of the signal. Again, analog signals are transmitted by various methods such as voice communication, video, images transmission. Analog signals are continuous signals which varies in amplitude and phase. Here you can see analog signals are the continuous signal, whereas the digital signals are baseband and passband signals are transmitted in the form of bits. The digital signals are transmitted in the form of the bits, whereas analog signals are the continuous. Again example, if we enter data from computer keyboard, eventually binary codes pattern generated for each key, which is digital signals. Various bit size can be used to represent, for example, 7 or 8. 7 bit size means it has 128 elements, means, and the for 8 bit size means 2 raised to power 8, it comes like to 56 different elements can be represented. Here you can see communication of signal needs to be efficient and reliable. Signal communication system can be represented using the below diagram. Here is source, then transmitter, then transmission path, receiver and destination, noise and interference. I will teach you each of this element in deep as we proceed in this chapter further. So here is the parallel communication of this signal communication system. So what is this parallel communication? Separate wires, for example, to transmit data, that is 8 bit or 8 wires are used. Here you can see it is the sender and it is the receiver. Here you can see on this diagram, here this is parallel data transmission. This is the sender and this is the receiver. Separate line for each element is present which is parallel to each other. Here again the second diagram, the sender and receiver. Data lines are present there, means to send each element you have a separate line, separate wire there. To transfer data on a parallel link, a separate line is used as a clock signal. This serves to inform the receiver when data is available in addition. Another line may be used by the receiver to inform the sender that the data has been used and it's ready for the next data. Here you can see the data lines, means these data lines are present here, and there is a separate line which also telling that this data is available there. For sending the signal, a separate line is available there which tells that data is available there, and another separate line is present there, or separate wire is present there which tells the sender that data has been used or the data has been not ready. So these are the various wires which we are going to use in this parallel communication. Again listen me carefully. In this parallel communication devices, the distance between the various subunits are very small. This unit difference between this sender and receiver or the subunits is very small. Data transfer through separate wires. The mode of transmission gives less delay in transferring each word. The advantages of parallel communication is that it is fast in communication, and its disadvantage, it is high in cost. Again here we are, this is communication. So each bit is sent over a single wire. You can see here it's between the sender and receiver, only a single wire is present there, and only each bit from this sender is sent via the same wire line here. Each bit is sent over a single wire, one after the another, means we are going to send this signal in the form of the bits one after the another. That's why we called it as a serial communication. No lines are used to convey clock, i.e. timing information. If no clock information was sent, the receiver would misinterpret the arriving data due to the bits being lost and going too slow. Here is no clock timing information is provided. There are two types of serial transmission depending on how the clock is embedded into the serial data. First type is asynchronous serial transmission, and second one is the synchronous serial type of transmission. So this is based on this clock information. Again listen me. The serial transmission always uses to transmit data from very long distance single line transmission data for fixed interval of time. It is its advantage, it is having a less cost, and its disadvantage, it is a slower in transmission and complex due to the conversion devices. Now on the basis of this clock information, we are again going to distinguish this serial communication as asynchronous serial transmission and synchronous serial transmission. So here we are. Asynchronous signal communication not require timing signal. Synchronous serial transmission, it does not require the timing signal, whereas the asynchronous serial transmission requires the timing signal. In asynchronous serial communication, both ends of the sender and receiver requires agreed pattern that the communication between the two ends happen. Signals consist of both data and control bits. In synchronous communication, receiver will easily separate out previous signals and currently arrived signal. This type of problem can be solved through adding a start and stop bit in signal. Okay. In asynchronous transmission, each bit remains timed in usual way, but in synchronous transmission each bit level time separately. Asynchronous transmission timed at a byte level. Asynchronous transmission is slower as compared to the synchronous because increasing the number of gaps. Asynchronous is more cheap, effective form of serial transmission and always used for low speed connection for keyboard and mouse, the mouse off connection. Okay, so again we are here, this asynchronous serial transmission. It sends one character at a time. Connect start bit and stop bit. Start gives indication to receiver for new group of data. Stop bit gives the indication to receiver to stop. It's more bandwidth is required in case of asynchronous data transmission, whereas in case of synchronous transmission not uses start and stop bit. It contains multiple bit in group, no gap in byte. Sender and receiver established between by timing of transmission of each bit. Receiver and sender operates at the same clock frequency. Application of the synchronous transmission, it is used in computer for high speed communication. It is used advantages of this synchronous system, that it is faster and it not required start and stop bit, but in case of asynchronous system it requires the start and stop bit. Okay, so here we are. Here we are going to see the difference between the serial versus parallel communication. So this is for serial. The data transmission is linear fashion for serial communication, and for the data transmission is simultaneously as single character. Then in single wire to transmit the data, but in case of parallel, multiple wires running in parallel to transmit the data. In series, so slower data transmission speed, but in case of parallel it is a faster data transmission speed. Data transmission over for a long distance we use the serial communication, but for shorter distance and fast we are going to use the parallel communication. Series, it reduces the noise and interference, but it in case of parallel it increases the noise and interference. Series is economical, means it is low in cost, but parallel it is the expensive data transmission. Example of series transmission is USB and then SATA, and in case of this parallel it is IDE connectors and PCI expansion ports. Here we are going to see again the synchronous and asynchronous signal communication. So here on the screen you can see that the synchronous data communication takes place between the sender and receiver. This is the type of serial communication. Synchronous in this, sender and receivers to be present at the same time for communication to happen. Block of data characters are transferred at one time. Here you can see block of data is transferred between the sender and receiver. These are the blocks. Here you can see this block are separated by this vertical line here. This time dependent communication, sender and receiver needs to be synchronized by external clock, means the time of the time setting of the sender and receiver should be the same. So that's why we called it as a synchronized signal communication. Here the transmission speed is fast, it is complicated and expensive approach. Example, telephonic conversation, chat, video and conferencing. You may have the problem arrive in case of this telephonic conversation, that whenever the time of clock is not set perfectly, at that time your phone function will not work, because it is a synchronous type of communication. Here in case of asynchronous, it is a start and stop, both the beats are present there. Start beat and stop beat are connected, and between this start beat and stop beat we have the data. This is the again this is the type of serial communication. In asynchronous, sender and receiver are not required to be present at the same time for communication to happen. Here data is transferred one bit at one time. Time independent communication, no clock signal use. It adds parity bit indicating start and stop of new bytes to data before its transmission. Transmission speed is slower, simple and cheaper approach. Its example of this asynchronous type are the emails and the message, where the presence of both the sender and receiver at the same time it's not required. Okay. So here we are stopping today. We will see about this analog and digital signals in the tomorrow section. We will see about this analog digital converter. We will see this next topic in the next section. Thank you for today's section. See you tomorrow.